Okay, in the last video, we saw horizontal concatenation, vertical concatenation, sort function. We also saw some broadcasting and stuff like so. Universal functions, it should be speed here. Sorry, it should be speed. Universal functions are really speedy. I always am talking about NumPy. Whenever I start NumPy, I said it is fast, it is fast, it is fast. I never show you how fast that is. So let me give you an example. Let me just create an NumPy array with a lot of numbers, and then just apply an ordinary function. Let's say I want to add all the numbers in this array B. Let's apply an ordinary function that is not in NumPy, and then let's use a universal function .sum and see how speed difference is there. If, for example, we apply a universal function to achieve a particular task, how speedy that universal function is, because the vectorized implementation, as I told you, is much faster. How faster? Let's check that out in your Jupyter Notebook. That's a magic command, time it, that will tell us how much time this particular task has taken. And if you run this command, it will call this function again and again several times, and then will report an average value that will be much more stable than just calling once. After that, we will also write our own sum function using loop, and we will see whether that is even closer to a universal function speed or not. Let us just check the speed of universal functions. That will give you a look and feel of how much NumPy implementation is faster. So let's say we have an array, let's say B, np.random.rand, and let's say that array is huge, really huge. That's the case. Now what we do is let's say we call a function sum. So let's say we call a function sum. That's a built-in function in NumPy. That's a built-in function. That's a built-in function in Python, not a NumPy function. And then let's say we do the same task using NumPy universal function np.sum. That's the same as np.sum is the same as if we write, for example, b.sum. So whether you write b.sum or you use np.sum and b pass as an argument, both these things are roughly the same. So let's run it. It will take a while. It will take a time because okay, the sum function takes 307 milliseconds. That is not a universal function in NumPy. That's Python function. That is not written in NumPy. That is not a vectorized code, nothing. It takes 307 milliseconds to take the sum of the elements of this array. And it does that by applying 7 runs and 7 loops. However, the universal function takes just around 3 milliseconds, I mean 2.7 milliseconds. How are you going to compare this 307 with 3? How much faster you are? Around 100 times you're faster. I mean, yeah. I mean, this NumPy is literally faster. NumPy, the universal function, they're faster. Maybe you attempt to know that, okay, this sum function might be too slow. Let me write my own function. To do that, let me define my sum, and my sum just take an argument, let's say something, let's say g, and what it does is for, let's say, s equals 0, what it does is for x in g, s plus equals to x, x plus equals to x, and then just return s. Let's say that's your function. Let's say you think that this is really a great function. Let's do that. Okay, let's compute the time for this. Time it, my sum, and let's pass the array B and see how faster this is. This is roughly the same as you're calling the sum function, but this np.sum or the universal function is way faster, way faster. So use universal functions, avoid for loops, avoid your own functions if the same task can be achieved through universal functions. whenever possible, avoid loops when you are working with NumPy. That's a serious suggestion. Follow that, because the universal function written in NumPy, they follow the vectorized code. All the interpreted slowness that is deferred to the compilation layer, and the NumPy becomes really faster and shows its power when you are working on large arrays using the universal functions. So I can speak more about NumPy, but I have told you some basics of NumPy, and we end the NumPy here, and from the next video we will be moving towards a very fancy and beautiful kind of package called pandas to handle data. And by the way, the pandas library, the pandas package, completely is built on top of NumPy. Everything that is there in pandas is built on top of NumPy. So all the indexing and all kind of stuff, slicing and speed, all is there in pandas that is due to the NumPy. So we will see one more package after pandas, which is matplotlib for plotting afterwards. And we'll do a project at the end using scikit-learn as well, just to wrap up all these things together. But for now, I'm ending NumPy here, and in the next video we will start pandas. Hope to see you in the next video.